What is the fate of the cosmos? How will the cosmos end? What will become of us? Well, in this episode, we utilize electrogravity-magnetic principles of space-time engineering to answer these questions. In doing so, we conclude that the universe experiences a cyclic rebirthing process, in some ways, analogous to the creation and annihilation of virtual photons, associated with the Casimir effect. Let's begin our journey. In order to save time and prevent duplication, we shall leverage off as much existing information as possible. Hence, prior to proceeding, we recommend that viewers review episodes 17, 18 and 19. With these episodes freshly in mind, and all recommended artifacts referenced in these episodes also reviewed, we're in a position to move forward. The standard model of cosmology conceptualization of the universe appears on screen. It's intuitive, simple and very easy to comprehend, however, it is profoundly limiting. A significant problem with this representation is that it does not visually communicate any aspect, or even the existence, of the quantum vacuum, let alone the quantum vacuum ground state, that is, the zero-point field. The standard model of cosmology representation of the universe is derived from general relativity. Unfortunately, the future of cosmology is not general relativity. The future of cosmology is the quantum vacuum, that is, the integration of general relativity with quantum mechanics. The most obvious integration point between these two disciplines is the quantum vacuum. It is important to note that, in the standard model of cosmology conceptualization shown, the diameter of the sphere denotes the size of the observable universe, that is, approximately 92 to 93 billion light-years. Illustrated on the right-hand side of the screen, is the quantum model of cosmology. The quantum model of cosmology is an equivalent representation of the standard model of cosmology, but also includes the quantum vacuum. The quantum model of cosmology is a sphere of Hubble radius, enveloping the quantum vacuum. Specifically, the quantum vacuum in its ground state, termed the zero-point field. The radius of the sphere changes with Hubble time, and the observable universe rests upon the surface of the sphere. This means that, in order to circumnavigate the observable universe, a traveler must move all the way around the sphere, returning to their starting position. By doing so, the traveler has moved approximately 92 to 93 billion light-years, which is equal to the diameter of the standard model of cosmology conceptualization on the left-hand side of the screen. In other words, the perimeter of the quantum model of cosmology equals the diameter of the standard model of cosmology. We exploit this relationship in order to derive some astonishing experimentally verified results, thus proving that the true age of the universe is the Hubble age. This is a 2008 illustration of cosmological history. We've had to make a number of changes to bring it up to date, but nothing too radical. This is what the standard model of cosmology looks like when it has been constrained by the cosmic microwave background radiation. We show cosmological inflation to be a period enveloping the Big Bang and very importantly, cosmological acceleration. This cosmic microwave background radiation constrained solution estimates the James Webb Space Telescope galactic structures to be 1.3 billion years old, not 2 to 300 million years. It also means that the apparent observations of galactic mergers actually occurred at approximately 1.5 billion years after the Big Bang, not 400 million years. Now that we have described the history of the universe from the Big Bang to the present epoch, let's look into the future. In our recommended artifacts, we claim that the flatness problem does not exist, and the curvature of the universe is presently barely open but on its way to becoming asymptotically open. Therefore, an obvious question arises, that is, what happens when the space-time geometry of the universe approaches its asymptotic limit? But before we propose an answer to this question, let's consider the fact that the universe recycles all forms of energy, nothing is ever wasted. We need to keep this in the front of our minds at all times. So, our answer to the question of what happens beyond the open universe asymptotic limit is cyclic cosmology, whereby the universe endures a never-ending cycle of Big Bangs. At the instant of each Big Bang, the dark matter and baryonic content of the universe is randomly configured. That is, with each Big Bang, The dark energy content is always 50%, but the baryonic and dark matter content can vary between certain limits. However, the values of baryonic and dark matter will always sum to 50%. Therefore, for each Big Bang, the total energy is always equal to 100%. The next thing we need to do is understand the processes commencing at the instant of each Big Bang. At this moment, the universe is 50% dark energy. This means that 50% of the total mass of the universe resides in the zero-point field as quantum potential energy. The remaining 50% exists in our physical universe as dark matter and baryonic matter. The process of virtual photons from the zero-point field popping into existence momentarily, before collapsing back into the zero-point field is the mechanism which drives cosmological expansion. Whilst this process is happening, other processes are also happening in parallel. For example, gravitons which were created at the instant of the Big Bang, are being absorbed by the quantum vacuum as well. We call this dark matter decay. Hahowever, not all gravitons are absorbed at the same time. Some gravitons are bound in matter, whilst other gravitons manifest as halos surrounding galactic structures, or possibly clumped in regions of space-time curvature, as described by the space-time wrinkles, associated with multiple recommended artifacts appearing in episodes 17, 18 and 19. We'll walk through this illustration shortly, but for now we need to make an important deep dive into the concept of cosmological matter-energy decay processes. It's important we do this, in order to help you understand the illustration you're seeing now, so, let's go. The cosmological matter-energy decay process is a necessary foundation underpinning cyclic cosmology. On this slide, we'll outline the key elements involved. Firstly, baryonic matter decays to dark matter. This is also termed liberating gravitons, hence, baryonic matter acts as a reservoir of potential gravitonic energy. Secondly, dark matter created in the Big Bang, and liberated gravitons, decay to dark energy. Thirdly, dark matter is indistinguishable from space-time curvature. And lastly, dark energy drives cosmological expansion via the widely accepted, virtual photon creation and annihilation process associated with the zero-point field, that is, the quantum vacuum, experimentally observable via the Casimir effect. Let's walk through the process graphically. At the instant of the Big Bang, baryonic matter starts decaying to dark matter. This means that the gravitons bound in baryonic matter are ejected, that is, liberated, at a constant rate. Upon liberation, they are immediately classified as dark matter. As already mentioned, dark matter is identical to space-time curvature. The function of baryonic decay is to provide the required energy to sustain the space-time curvature of the manifold surrounding the baryonic matter. The dark matter either decays, that is, it is absorbed, immediately into the zero-point field, becoming dark energy, or decays proportionally according to the Newtonian inverse square law, and then becomes dark energy. At the zero-point field boundary, all gravitons, which are conjugate wave function pairs of photons, decouple upon entering the zero-point field, but remain entangled. However, given that no process is 100% efficient, a very small fraction of decoupled photons part company. This means that one photon enters the zero-point field whilst the other photon does not. The photon escaping zero-point field absorption propagates through the universe in the conventional manner, becoming part of the cosmic background noise. Let's now get back to understanding cyclic cosmology. The overall cyclic cosmology process is such that all matter evaporates into gravitons, which are then absorbed by the space-time manifold. Once inside the space-time manifold, they've entered the zero-point field, which is the home of all dark energy. Once it has decayed to dark energy, it is available to assist the expansion of the universe. So as you can see, the evaporation of matter is the engine driving cosmological expansion. Let's now walk through the illustration. We see that in period A, which includes the Big Bang, the zero-point field is already 50% filled with dark energy. That is, 50% of its cosmological mass already exists as quantum potential energy. The baryonic matter which has been created, immediately commences decaying into gravitons. Period A represents the time taken for all baryonic matter to fully evaporate, that is, decay into gravitons. As you can see, this is an enormously long period of time. Before we take a look at period B, we need to sow a bit more detail into the dark matter story. As discussed several times previously, the free gravitons associated with dark matter are absorbed by the zero-point field, becoming dark energy, that is, quantum potential energy, and contributing to cosmological expansion. However, a graviton is defined as a pair of entangled conjugate photons. Because the pair of photons are conjugate, their wave functions cancel. This does not mean that their energy is destroyed, it simply means that it doesn't propagate. In other words, a graviton has reach, but it doesn't propagate in the usual sense, and baryonic matter acts as a reservoir of potential gravitonic energy. So, period B denotes the time required for photons created at the instant of the Big Bang to enter the zero-point field. Let's not forget that countless photons were also created at the instant of the Big Bang, which are free to propagate through spacetime as the universe expands. Period B also denotes the time required for gravitons created at the instant of the Big Bang to either decouple into at least one propagating photon, whilst the other photon is absorbed into the zero-point field, or for both photons to be absorbed by the zero-point field. Period C represents the time required for all cosmological mass energy to have been absorbed by the zero-point field. Period D represents the time required for the cyclic cosmology process to repeat itself. The reason why the duration of this period is twice the duration of the previous period is due to the bidirectional photon exchange process between our physical universe and the zero-point field. That is, on average, for every 2 photons entering the zero-point field, 1 photon is returned to the physical universe. Bidirectional photon exchange is required in order for the Casimir effect to work. Without virtual photons popping into existence and becoming real photons, the Casimir effect would be absent. Therefore, for every 2 real photons entering the zero-point field, 1 photon is returned from the zero-point field to the physical universe. This process is the origin of the Casimir effect. Here we see a bit more detail with respect to the randomized Big Bang configuration, and the matter evaporation process into the zero-point field. At the instant of the Big Bang, the dark energy density is fixed at 50%, this applies to all cosmological cycles. This means that half of the total mass in the universe exists as quantum potential energy within the zero-point field. Random emergence of virtual photons into reality is the mechanism for cosmological expansion. Space-time expands in response to an input of energy introduced by virtual photons popping into reality. With each Big Bang, the quantity of baryonic matter created is randomly set to less than 23.7%. Similarly, the quantity of dark matter created is greater than 26.3%. However, the quantity of baryonic matter and dark matter combined always equals 50%. Now, let's do a deep dive into the matter evaporation process. We can see here that at the instant of the Big Bang, the zero-point field contains 50% of all the mass in the universe, existing as quantum potential energy. This means that the zero-point field is in a completely unsaturated state, ready to receive energy from the physical universe. An instant after the Big Bang, baryonic matter begins to lose mass by radiating gravitons. It takes period A for all matter to evaporate to gravitons. Once gravitons have been released by baryonic matter, they immediately commence being absorbed by the zero-point field. This means that the absorbed gravitons have separated into virtual photons but remain entangled. Residing within the zero-point field is quantum potential energy. The time required to complete this process is termed period B. It is interesting to note that the decay of gravitons adds to the Casimir effect on a cosmological scale. By the end of period C, all matter and energy has been absorbed into the zero-point field, including the free photons and free gravitons left over from the Big Bang. By this stage, the zero-point field is only 50% saturated, and the bidirectional photon exchange process continues. During period D, the bidirectional photon exchange between the physical universe and zero-point field is the engine driving cosmological expansion. Even though all physical energy has been absorbed by the zero-point field, it is randomly returned to the physical universe via the Casimir effect. This process may be described as quantum vacuum evaporation. For every 2 photons entering the zero-point field, 1 photon is rejected by the zero-point field and enters the physical universe. This process continues until the end of period d, when the zero-point field is 100% saturated with quantum potential energy, also termed virtual photons. The cyclic cosmology, baryonic and dark matter limits, are graphically represented here. The first important point indicated is the present epoch, that is, our present cosmological age. This sets the scale of the graph. Next, we see the curve representing the standard model of cosmology's dark energy density parameter, followed by the instant when, itself, and the cosmological constant equaled 0. The solid red line represents the maximum percentage of baryonic matter which can be created in any Big Bang cycle. This is the 23.7% limit. The solid magenta line denotes 0% baryonic matter, and the solid blue line represents our universe, which contains approximately 6% baryonic matter. The dashed red line denotes the deceleration parameter associated with the maximum baryonic limit of 23.7%. The dashed magenta line denotes the deceleration parameter associated with the minimum baryonic limit of 0%, and the dashed blue line denotes the deceleration parameter configuration for our universe, with approximately 6% baryonic matter. Note the value of deceleration parameter obtained if one utilizes a dark energy density value of approximately 68%, instead of 50%. Finally, various graphical intercepts between the pressureless matter parameter and deceleration parameter have been identified. Thus far, we have investigated cyclic cosmology on macro and micro-scale timelines. The macro scale refers to the period of time for one complete cosmological cycle, whereas the micro scale refers to the current age of the universe. From the macro scale, we have seen that, on average, 2 photons enter the zero-point field for every photon exiting it. However, on the micro scale, from a moment after the Big Bang to 7.3 billion years, the zero-point field releases more photons than it accepts. Hence, the zero-point field is expelling more photons into the physical universe than absorbing photons from the physical universe. Moreover, bidirectional photon exchange is biased to flow from the zero-point field into the physical universe for the first 7.3 billion years. Let's now summarize what we've learned. Number 1. Baryonic matter decays to dark matter. Number 2. Dark matter decays to dark energy. Number 3. Dark matter is indistinguishable from space-time curvature. Number 4. Dark energy drives cosmological expansion. Number 5. For every 2 photons entering the zero-point field, 1 is returned to the physical universe. This is experimentally observed via the Casimir effect. Number 6. The minimum lifetime of all baryonic matter has been calculated. And number 7. An approximate value of cosmological cycle period has also been calculated. For viewers wishing to consult literature relevant to this episode, you may do so by accessing the link shown.